Hello, Mr. Fry's Algebra 1 class. Some in notes. This was done in class on the 8th today, Monday. In case you need this, these problems, in case you need these problems done. I got the odd ones definitely done, some even ones in there for you in case you need them. They only did 1 through 4 in class. I'm going to have some extra ones because I imagine you're going to be taking a look at these at a later date, tomorrow possibly. So let's take a look and see what's going on here. Since y's are, it's telling you what each y equals, we're going to set them equal to each other because y would equal y. Why not? So I set these equal to each other and I solve for x. Just combining my like terms, isolating the variable, and I get x equals -2. Then I plug this -2 into one of the problems, and I chose the first one. The first one because it looked a little bit easier. I don't know, maybe it's just because it's first. They both look very easy. So I just plugged in that -2 instead of x now because that's what x equals, and I solve for y, and I get y equals -9. So I get -2, -9. The way I would set up number 2 is like this to get you started. This is what y equals, so I'm going to substitute this y with 6x. And then just go ahead and work it out and solve for x. Take your x value, plug it back into, I would pick this one, so you can figure out what y equals pretty quickly and easily. For number 3, this is what y equals. So I'm going to plug this amount in for y. I used the distributive property. That's how I got these numbers. I combined my like terms and I subtracted 72 from both sides. I did 2 steps in there so because I didn't have much room. I divide both sides by 11 to get x by itself. -77 divided by 11 is -7. I plugged -7 into this first problem because that was the easier one. So -7 plus 9, my x plus 9 is now -7 plus 9. I get y equals 2. And so that's the point of intersection for those two lines. And these two numbers, if I were to plug them in, they would satisfy both of these problems. So if I were to plug -7 in for x, -7 plus 9, guess what that equals? 2. Yep, 2 as my y. If I plug in my -7 here for x and my 2 here for y, and I work this out, I would get -5. Okay, this x amount is 4y plus 7. I just plug that in for my x amount, right? I use the distributive property. I combine my like terms, and I also subtracted 14 for both sides. I end up with y equals -1. So with my y equaling -1, I plug in my x value. I used the first one because that was the easier one. Instead of x, or I'm sorry, instead of y, I put in that -1. I work it out to figure out what x equals. X equals 3. Okay, some more problems that we didn't do. We didn't do the back today, but I imagine you'll do them tomorrow, so you might as well take a look at this, and you could utilize this. Maybe you're looking at this on Tuesday. And these would be some of the problems that we're doing on Tuesday, I would imagine, in class. I have to rearrange this so that it's just y. So I subtracted 2x from both sides. This I substitute in for y, and so my problem looks like this now. I use the distributive property. I combine my like terms. Add 6 to both sides. End up with negative x. I don't want to know what negative x is. I want to know positive, so both sides I divide by -1, and I get x equals 2. Now I know what just my x equals. I plug that 2 in for the x value, and I end up getting y equaling -1, or I'm sorry, -6. So 2 -6 would be your answer. For number 7, I just rearranged this. I just subtracted 5y from both sides, so I know just what x equals all by itself. So I plug that in. After I plugged that in, I noticed that once I start combining my like terms, I get rid of my y's. And I just have a 12 on the side of -1. 12 does not equal -1, so it's a no solution. No solution. If you were to rearrange these and put them both into slope-intercept form, you'd see that they have the same slope. Okay, they're not the same equation, but they're the same slope. Okay, so that means they're never going to intersect, so there's not going to be a solution. Now number 9 is it's kind of similar. I rearranged this, so I just subtracted 2x for both sides, so I know what y only equals, so I plug that in for my y. So that now I'm just working with x's. I solve this, I end up getting 54 equals 54. Well, yeah, that's true. So when you have something like this and you got rid of, your variable there, that means infinite solutions. That means they're actually the same line. So I don't know if you noticed this, but if you were to divide everything up here by 3, you would get the exact same. You'd get 2x plus y equals 18 if you divided everything by 3. It's the same equation. So it's going to be right on top of each other, so it's going to be infinite solutions. It's intersecting everywhere because it's the same lines on top of one another. If you were to draw it out on a graph. For number 11, I just rearranged this one. I subtracted 3x from both sides, but then it tells me what negative y is. This is a minus y. So then I have to, for both sides, multiply both sides by a -1 to get just y by itself. And so I end up with y equals 3x plus 8. Plug that into my y value. Here it is. I use the distributive property, combine my like terms, isolate the variable. I get a -11 divided by 11, x equaled -1. I plug in that -1 into the first problem because that was the easiest one. And I get 3 times -1 minus y equals -8. Multiply all that, or isolate the variable, and I get y equals 5. So you should have -1, 5 for your number 11. Hopefully this helps you out. Hopefully this helps you out 2 days, not just one.